Hello everyone, my name is Ravi Choudhary and I'm going to discuss about this paper published on IEEE in 2018, that is privacy preserving image processing in the cloud. And in this paper, four researchers has contributed, that is Jan Quinn, Zia Wang, Zon Kui and Qiran. As we already know that there is many image processing applications, and since there is a limitation of computational power in our devices, so we need the CSP, that is cloud service provider. So we're going to discuss about this paper in a brief. So this is our problem statement, that is image processing in a cloud computing platform which could enable any fancy image processing based application on devices with limited computational power. And to ensure the safety and privacy on the cloud is the biggest task to make the upcoming cloud service more robust to privacy preserving image processing system. So this is our challenge, how we can process all the image processing task of the server with the having better privacy preserving system. So we will discuss about this in coming slides. What are the technique? What are the challenges? How we can counter them? How we can have better robustness in our existing processing image processing system. If I talk about the solution that were discussed in this paper, is that there is a system, and if I talk about the system, there are few technique which should be followed. That first is that we should convert our image to encryption code, and then only we can do the all operational activity of the server. And after having done with the operation or multiplication task, I should again decrypt my code and send the actual output to the user. It's a kind of encryption description or encoding decoder were involved in the system model. And the second is the formulating design target. If I talk about the design target, there are three aspects in design target. First is the functionality, how what functionality I am getting through my image processing system. Second is the security, how much robustness is in our system. And third is the efficiency, how much efficiently I can do the all operational computational task over the server. And one more thing, the state of the art technique, including homomorphic encryption and secure multi-party computation are also discussed. If I talk about the homomorphic encryption, is like the encryption of the data into a code. And in secure multi-party computation is basically we transfer our data to multiple server, so that we can have a better chance or have better option not to get threat over the cloud. And the third is the integration of different technique, because what we have, so what I will going to discuss in the coming slide is that not even a single technique scripting tools is well enough to perform all kind of applications, mm, processing tasks. So we need a combination of every scripting tools so that we can perform our task as per our requirement. This is a brief about our solution, which we have discussed or will going to discuss in the coming slides also. Novelty. In this paper, there's two feature detection technique were mentioned. The first is the global, and the second is the local. In global feature detection, they have used the SHE, that is somewhat homomorphic encryption. Basically, it's a subset of the FSHE, and they have used the MPEG-7 is the encryption tool. Basically, it's the advanced tool. Prior to that, we were usually use MPEG-3 and 4, and in this we use XML to store metadata, and we can also attach the time code to it, add an extra security layer to our existing data set. And in local feature detection mechanism, uh, we have mentioned that scalar invariant feature transform can be used. It can generate a public encrypted key which can be used to identify our data or our uh, image uh, important feature. And in scalar SIFT, what we do is basically we identify the important pixel and we create a small circle ring around them. But there are chances of to threat in those important pixels also, because if this is a usual thing to identify the most important pixel. So if uh, end user of the third party want to steal our data, that can protect that trend and can manipulate with the data. So to avoid those kind of activity, what we can do is we can divide our data after SIFT into a different part, and we can send it to a different server so that we can have a better like safety and security on the server, because single data is not available on one server. So that is the task which we can perform after having SIFT. And if I talk about digital watermark, there were two concepts were discussed. That first is asymmetric watermarking, the second is zero knowledge watermark detections. Basically, in the digital watermarking, is what they have said is that during the processing of the watermarking image, where we can separate the digital watermark with the actual image, and all the computation tasks are performed on the image, and after getting the result, we can again impose all. We can again impose a digital watermark. In that way, we can maintain the flow of the digital watermark, and we can also maintain the privacy to whom that particular image belongs to, because it's very difficult to encrypt the digital watermark. So it's better to not much get involved in the encryption of digital watermark. The third is the secure image retrieval mechanism will also propose that if we are sharing our image data, or if we are doing some image processing time, if we use our location-based detection service also, that will add on one more extra layer to protect our data, and we can protect from the similar evaluation of our existing system. And privacy protection, image data processing, as I discussed in the previous slide, there is a system model with a design target. We take care of it during the processing of all the image. And in terms of encryption homographic code, there is a technique, two approach were used. First is the FSHE, or I can say SHE, somehow homographic encryption, and the second is the SMC. Both have some advantages and disadvantages, and I will going to discuss this in the coming slide. As I mentioned, as a secure multi-party communication is that it divides our existing image and transfer into different server, that is on server 1, server 2. So suppose server 1 contains 60% of the data and server 2 contains 40% of the data. So overall, they have a 6 to 2 ratio. So if someone tries to steal our data, so they have to tag on both the server. So it's a kind of very less, probable option to access both server and align all the computation in all the component in the right way. It's a kind of very difficult for the uh, settling task, because it give you extra leverage for us and give extra privacy during the image processing task over the cloud. And in terms of critics, like as I mentioned that we have used SHE in comparison to FHE, because FHE have huge computational complexity. We can't afford that, so SHEs provide a like alternative better approach. And but there is also limitation in SHE. There's a limited number of multiplication operation, so it's a kind of limited application. But we can use SMC technique to avoid the limited multiplication operation, and it has provided quite good result on many applications. But there is one more SMC operation of a cipher type domain require 10 to 100 iteration of homographic addition, and multiplication operation. So it seemed impractical to use only homomorphic encryption based technique to realize all the functionality. But there is a kind of uh, trade-off between the functionality of the computational power. So kind of compromisation has to be done when you are using assembly technique. So and then and the as a better interpretation of this image processing over the cloud is that we don't have a single technique where we can uh, perform or get the best uh, output, or we can get the best uh, expected result. We have to compromise on either on the functionality efficiency or on the number of operations. And this is also the scope of improvement also, that we should create a builder technique where we can, we don't need to compromise those functionality of the computational power. We should have that kind of technique where that will be available for all kind of problem, and we have better kind of uh, security over the processing of the image on the server. I hope I tried to give you a brief introduction about the privacy of image processing on the server in the cloud. And thank you so much for watching this video. Have a good day.